Let's add fractions like a math snob. So example number 1. We're going to start off easy. 1/2 plus 2/3. So this plus symbol asks us a question. It tells us that we have one term plus a second term. And so this symbol asks us a question. And the question is, are they, meaning the two terms, like? And the answer to this could be yes, and it could be no. If we're just looking at it from a term and a term point of view, they're like, and that this is a fraction and this is a fraction. So we would say we have two fractions. But this is asking us, it's an operation, it's asking us to perform something, it's asking us to actually add them together. So our are they like question has to change a little bit. It's are they like, are they similar in size? Are they the same types of pieces? And the answer to this question is no, because this takes a whole, which I'm going to represent by a rectangle, and cuts it in half. And it tells us that we have one of these. That's all we have in our pocket, right? The other denominator is 3. So that tells us that we have this whole, right? And our wholes are going to be the same, right? And it's cut into pieces of 3. And this tells me that I have 2/3 of them. So are they like? Ask yourself, is this piece of 2 the same size as a piece of 3? And the answer to this question is a big, huge no, which makes us sad, which tells us that we now have to go in, and what do we get to do? We get to fix it. By getting a common denominator is to turn this piece of 2 and these pieces of 3 into smaller pieces that are of the same size. So in essence, what we're going to do this time is we're going to take that piece of 2 right here, and I'm going to cut it into 2 smaller pieces itself. So I'm going to take this piece of 1, or this piece of 2, and I'm going to cut it, and I'm going to cut it, which is that this piece of 2, which represented 1/2, right? If I cut the half of the half into pieces, then I have to cut the half that I don't have also into the same size pieces, which means that my new whole isn't made up of pieces of 2, it's made up of pieces of 6. So we've got 1 piece, 2 piece, 3 piece, 4 piece, 5 piece, 6 pieces, which means that my 1/2 really is the same thing as 3 pieces of 6. 3 pieces of 6 is the same thing as my 1/2. It's like going into the store with a whole dollar bill, or I can walk in carrying 100 pennies. Aren't my 100 pennies and my $1 bill going to be able to buy the same amount of the same thing? It's just that the currency I'm holding looks different. So I could walk into the store with 1/2 of something. You could walk into the store with 3/6 of something, and both you and I are going to be able to buy the same item because we're carrying the same value. It just looks different. So let's do the same thing with our pieces of 3. So I'm going to take my pieces of 3 and I'm going to cut each one of them in half. But I also have to cut in that piece of 3 that I don't have also in half, which means that the 2/3 that I started off with has now turned into 1, 2, 3, 4, 5, 6 pieces of 6, of which I have 4 of them. So my 2/3 is going to be equivalent to your 4/6. So now that we're both carrying pieces of 6, what do I really have? I have 3 pieces of 6, and I have 4 pieces of 6, right? So then what does that get me? That gets me 7 pieces of 6, right? Here's 3 pieces, here's 4 pieces. What does that get me? It gets me 7 pieces of 6. So now that they're like and that they're both pieces of 6, I can now count the pieces, because that's what adding really is, counting the amount that we really have. And I can say that I have 7 pieces of 6. Now, how do I do that mathematically so that I don't have to go around creating these crazy shapes? Enter the term FFO. Fancy forms of 1. What's a fancy form of 1? 3/3. I have a whole. I have all 3 pieces. 6/6. I have a whole. And I have all 6 pieces. Some fancy forms of 1 look strange. They look like the square root of 3 over the square root of 3. They look like x plus y over x plus y. It looks like 1.679 over 1.679. As long as my numerator and my denominator are the same, it means I have 1 whole. So mathematically, what are we doing? We are taking our 1/2, and what do we do with our 1/2? We cut it into pieces of 3. So my fancy form of 1 I'm going to use is 3 pieces of 3. Okay, I'm taking my 1/2, and mathematically I'm multiplying it by 3 pieces of 3, which is a fancy form of 1, which has a value of 1, so I'm not really changing the value of 1/2, I'm just changing the way that it works. Plus 2/3. What do we do with each third? Here was a third. I cut it in half. So what's my fancy form of 1? My fancy form of 1 is going to be 2/2. Right? Once again, this is a fancy form of 1, has a value of 1. I'm multiplying them. Anything multiplied by 1 is itself, so I'm not changing the value. And I still just have a term plus a term. It's just that this term has some fixing to do, and this term has some fixing to do before I can go ahead and add them. Now, how do we multiply fractions? Straight across. So my numerator becomes 1 times 3, which is 3, divided by 2 times 3, which is 6. So my 3/6, which is what we got over here, shows up in this term right here. Bring down your plus. How to multiply fractions? Straight across. So 2 times 2 is 4, divided by 3 times 2 is 6. And my term is still itself, and it's still the same value, 4/6. So now they're like. So then what do I say? I have 3 and 4 pieces of 6, which gets me my 7/6. There you go. Adding fractions. Okay, now you. Practice on 4/9 plus 5/7. Stop the video, do your work, come back, and see how you did. Okay, so how'd you do? Ask yourself, are they like? Nope. So get a common denominator by pulling out your fancy forms of 1. Fancy form of 1 is going to give us a new denominator of 63. So now I have 28 pieces of 63 and 45 pieces of 63. So my 28 pieces and my 45 pieces of 63 are going to get me 73 pieces of 63. How'd you do? Let's do another practice. Okay, practice number 2. 5/8 plus 7/3. Go ahead, work it, come back and see how you did. Okay, check your work. How'd you do? Did you get your 71 24ths? If not, can you find your mistake? And if you can find your mistake, can you fix it? Okay. Thank you for your time. Hope this helped. Drop a comment, ask a question. See you soon.